Here equations in polar form. U r equal to 1 by r v theta and v r equal to minus 1 by r u theta. So now you know, as usual, u r is nothing but dou u by dou r. U theta is nothing but dou u by dou theta. Vr is nothing but dou v by dou r. V theta is nothing but dou v by dou theta. So now these two equations, u r equal to v r equal to, is called CR equations in polar form. So now as usual, how we will do problem in Cartesian form x comma y. If f of z is a analytic, then CR equations satisfies. Next, partial derivatives continuous. So this we already discussed. So if f of z in a Cartesian form, if f of z is an analytic function, then what it will do? It satisfies CR equations and partial derivatives are continuous. So now the same thing is applicable in polar form also. So now based on these are the very rare case problems, we will discuss one problem on this. Question: prove that f of z equal to z power n is positive integer, is analytic function for all values of z, hence find its derivatives. So now for this problem we will try to apply the polar form. That means satisfying CR equations in polar form, that we will try to apply here. So now f of z equal to z power n. So in polar form, let z equal to r into e power I theta, which implies f of z equal to right side r into e power I theta whole power n. So now separate the powers, r power n e power I theta whole power n. So now again r power n, for example you have a power m whole power n, its value a power mn. So e power I theta whole power n, e power you can write I n theta. This is f of z. So now what I am doing means, you know e power I theta cos theta plus I sin theta. So the same thing we are applying in theta plus n theta, that is nothing but r power n cos n theta e power I theta cos theta plus I sin theta, e power I n theta cos n theta plus I sin n theta. Okay, now multiply r power n cos n theta plus I into r power n sin n theta. This is your f of z. So now the f of z, here given f of z is z power n. This z power n we are converted into polar form. So now here u is equal to, compare with, if you want more clear, compare with f of z equal to u plus iv. So u equal to r power n cos n theta, r power n cos n theta, v equal to r power n sin n theta. Okay, you got u and v. So now what we will do means we will try to check the CR equation whether satisfying or not. Then we decide it is analytic or not. So now dou u by dou r. So partially with respect to r power n differentiation n into r power n minus 1 cos n theta as it is. Dou u by dou theta. With respect to theta partially r power n constant. With respect to theta r power n constant. Cos n theta differentiation minus sin n theta, chain rule n theta differentiation n. So this will be minus n into r power n sin n theta. You got dou u by dou theta. Next dou v by dou r. Partially with respect to r power n differentiation n into r power n minus 1 sin n theta constant as it is. Next dou v by dou theta. Partially with respect to theta r power n constant, sin n theta of differentiation cos n theta, cos n theta, dou v by dou theta partially with respect to theta r power n constant, sin n theta is a cos n theta into n theta differentiation n, that is nothing but n into r power n cos n theta. So you got all the partial derivatives, dou u by dou r, dou u by dou theta, dou v by dou r, next dou v by dou theta. So now we check whether that CR equation satisfying or not. When you see just previous page, u r equal to 1 by r v theta want to be satisfied. We will check that. So now dou u by dou r equal to, what you are dou u by dou r? N into r power n minus 1 cos n theta. So now this we can write n into r power n r inverse cos n theta, n into r power n by r cos n theta. Okay. So now this will be, see this n into r power n cos n theta, n into r power n cos n theta, observe this, n into r power n cos theta. So if you want more clearly, 1 by r n into r power n cos n theta. See this n into r power n cos theta, that is nothing but dou v by dou theta. So therefore 1 by r dou v by dou theta. What is the left side? Dou u by dou r. So that is u r is equal to 1 by r v theta. So first is CR equation satisfied. Now we'll check the second one. So now what is second? Vr equal to minus 1 by r u theta. That is, we'll take Vr means dou v by dou r. Dou v by dou r equal to what we have, n into r power n minus 1 sin n theta. So now can I write n into r power n r inverse sin n theta. So now can I write n into r power n by r sin n theta. So this what I am doing means one by r n into r power n sin n theta. Do one thing, multiply minus inside outside, minus into minus plus. So now here minus n into r power n sin n theta, minus n into r power n sin n theta. What is that value? Dou u by dou theta. Minus n into r power n sin n theta dou u by dou theta. So this minus 1 by r as it is, minus n into r power n sin theta dou u by dou theta. So what is the left side? Dou v by dou r. Therefore Vr is equal to minus 1 by r dou u by dou theta. So therefore CR equations are satisfied. So now CR equation satisfied. After that checking partial derivatives, whether partial derivatives are continuous or not. This is our partial derivatives now. Take any n value and take any r value, theta value. You will get the finite only. Why? Because cos and sin range is in between. Cos sin ranges are always in between minus 1 to 1. So whatever the theta value, whatever the r value, you will get the finite only, partial derivative. This is also finite. So this is also finite. This is also finite. All partial derivatives, dou u by dou r, dou u by dou theta, dou v by dou r, dou v by dou theta, all are finite numbers only we will get. So therefore partial derivatives are continuous. You just mention like a clearly, just one word, clearly, partial derivatives continuous. So one more time, this partial derivatives, dou u by dou r, dou u by dou theta, dou v by dou r, dou v by theta, you take any theta and r value, you will get the finite only. When you are getting finite means these partial derivatives are continuous. So CR equation satisfied, partial derivative is continuous. Therefore f of z is analytic function. So now f of z means who is that given problem? F of z equal to what is that? Z power n. That means z power n is analytic function. That is z power n is analytic function. So now after analytic function, we is asking one part of the question is completed. Prove that z power n is analytic function. This is completed. Hence find its derivative. Next we will try to find its derivative. to find z power n derivative. So now to find z power n derivative, we have the formula. What is formula means? Remember this formula, f dash of z equal to 1 by e power I theta. This is a formula, ur plus I into Vr in polar form. This formula is in polar form. Polar form f dash of z. Okay. So you have to remember this formula, then only we can able to find. In polar form, f dash of z formula 1 by e power I theta ur plus I into Vr. We have already other values. So now f dash of z equal to 1 by e power I theta ur, just now you are calculated, ur here n into r power n minus 1 cos n theta, n into r power n minus 1 cos n theta plus I into Vr, n into r power n minus 1 sin n theta, n into r power n minus 1 sin n theta. So now we will try to simplify this. So now 1 by e power I theta, or what we can take common, n into r power n minus 1 common cos n theta plus I sin n theta. So now 1 by e power I theta n into r power n minus 1 cos n theta plus I sin n theta. So this is nothing but e power I n theta, like e power I theta, what is that, cos theta plus I sin theta. So cos n theta plus I sin theta, e power I theta cos theta plus I sin theta. Theta means theta. So cos n theta plus I sin n theta is nothing but e power I n theta. So now this will take into numerator this e power I theta, n into r power n minus 1 e power I n theta, this is e power minus I theta. Bases are same, power should be added, n into r power n minus 1 e power I n theta minus I theta. So now n into r power n minus 1, we can take common I theta common. So e power I theta common, so n here minus 1. So you have like this, a power mn, you can write a power m whole power n, your school standard formula, n into r power n minus 1. So this we can write e power I theta whole power n minus 1. Okay. So now you have like this, a power m b power m, sorry, yeah, a power m b power m, it can be written as a ab whole power m. When powers are same, so ab whole power m, r power n minus 1 e power I theta whole power n minus 1. So this can be written as n into r into e power I theta whole power n minus 1. So what is r into e power I theta starting? What we have taken in polar form? Z equal to r into e power I theta. That means r e power I theta is nothing but the z. So therefore this is z, z power n minus 1. So this is your f dash of z. So what is your n into r into e power 8 eta z, z power n minus 1. So you got f dash of z. So this is by applying the CR equations we did. For example, directly z power n is given. Short question, z power n is given. What is its differentiation? N into z power n minus 1 directly. Here we are applying all the process of analytic function concept and we are trying to find. So you may get doubt. For example, this problem, this f of z equal to z in f of z equal to z power n, uh, can we do in xy format? That means like a previous analytic function in Cartesian form. Cartesian means xy. Can we do in xy form means? Yes, we can do, but here what will get means when you take z power n, that is x plus iy whole power n, this expansion get complicated. So that is the reason we are applied polar form. We got simply this you can expect like a long question, 5 marks, 6 marks. Thank you.